So under this refraction plane surface,
So I hope my audio is audible.
in this only first glass slab applications I will explain, and T.I.R will discuss. The prism is refraction on inclined surface we can discuss, and curved surface already I made one video. So again I will discuss some points about the curved surface. So coming into refraction is the phenomena when light traveling from one medium to another medium, it takes the bending at interference, it takes deviation at the interference of two media separated. That is because of the change in light velocity from one medium to another medium and depends on the nature of the medium. So here the speed of the light is more than that media is called rare medium. Speed of the light in any media is less, that media is called denser medium. So this the rare media and denser media based on the velocity of light is divided, and based on refractive index also you can divide. So refractive index is the property of optical density, the media's optical density. Optical density and mass density are different. Optical density means refractive index. So this is ratio of the velocities. N is equal to C by V, the ratio of velocity of light in the vacuum with respect to media. So whereas mass density is equal to mass by value. Mass optical density more means that is called denser medium. In some of the cases, its mass density also more, but not always. So kerosene has less mass density but optically denser it is, so denser medium than water medium. Compared to water medium, kerosene have more mass density, mass per unit area, means kerosene's water density is equal to density of water is equal to 1000 kg meter cube, meter by kg by meter. So whereas density of kerosene is equal to 800 kg by meter cube. This is mass density, mass per unit value. So where the optical density of the kerosene is more than water, means for light the kerosene act like denser medium than water medium. And when it is light traveling or refracting from one medium to another medium, so properties, the velocity, wavelength of the light or color changes, but frequency does not change. Frequency means wave number or the number of vibrations by the light in the media. So frequency does not changes, depends on wavelength and lambda. This velocity of the light velocity and light wavelength, medium to medium will differ. So that medium is denser, so velocity is less, automatically wavelength also less. So velocity is more, that medium is rare medium. And in the denser medium, light bends towards normal. That means traveling from rare medium to denser medium bends towards normal. The light traveling from the rarer denser to rarer away from the normal. So this is denser medium here, denser to rare medium. By the angle of given refraction, we can tell the media is denser or rarer. Refracting angle is less in that media, that is denser. Refracting angle is more than incident angle, that is rare. Finally, the refraction means when traveling from one media to another media, the light deviates its path towards normal or away from the normal, depends on the from which medium to which medium it is traveling. The rarer to denser or denser to rarer. Similarly, the refractive indexes are two types. One is absolute refractive index and relative refractive index. So absolute refractive index means the ratio of the light velocity in the medium to vacuum, and this value is always more than 1 because C value is more. The relative refractive index is the refractive index of medium one media with respect to another media. So here the N12 are like this, N12. That means refractive index of 1 with respect to 2. N1 by N2. N21 means refractive index of 2 with respect to 1, N2 by N1. According to many authors and books, N2 is always refractive index of denser medium. In all the authors that are taken like that. And somebody will go with refractive index as letter mu. but for me convenience I am taking letter n. Okay, that is always. So n2 is always refractive index of media, refractive index of denser media. And actually the refraction phenomena, reflection phenomena and rectilinear phenomena are the phenomena explained by Newton corpus theory. That means light considered as a particle. So the refraction is a phenomena, attraction phenomena of particles. The light attracted by the particles of medium. The whereas the reflection is a repulsion phenomenon. So after that, after Newton corpus theory, those points and all after suggested and the given run by producing the giving the ideas of Huygens wave theory, Maxwell quantum theory, and de Broglie wave theory. So after that, the wave nature came to explain the remaining properties of light, dispersion, scattering, interference, photoelectric effect, and all. With that wave theory and wave explanation, we can explain this reflection refraction also. These phenomena also are such. And light have dual nature, means depends on the surface on which size it is incident. So it is considered as a wave or like ray. Right. So coming into laws of refraction, Snell's law. So Snell's law stated that. So according to Snell's law is not equal to sin A by sin A. So in some of the books they write Snell's law is equal to sin A by sin A. So this is only valid only for a light ray is traveling from rarer to denser medium. So whenever you want to apply the Snell's law for solving the problems, so this is very important formula and the point what I am going to tell now. The refraction on plane surface and curved surface, whatever the problem, only the one formula I have to apply Snell's law. So that is why I'm trying to give how to apply the Snell's law for in all the cases. So according to Snell's law, refractive index into sine of the incident sine of the angle in that medium, either incident or refracted, means n into refractive index into sine of incident or refraction is equal to for example here in n1 media incident angle is there, means in n2 media automatically refracting angle will be there. So that is equal to the product of n into sine of the angle of incident or angle of refraction is constant. So example here I try to explain. See, the rarer and denser, the light ray is traveling from denser to rarer, so it is given like this: nd into sin r equal to n1 sin r. So here nd by means nd means denser medium refractive index, n2 by n1 equals sin r by sin r. So whereas rarer to denser, n2 by n1 equals sin a by sin r. This is Snell's law. Snell's law is given for this application, rarer to denser. So this is the general phenomenon, the general explanation of refraction by Snell's. So that means whenever you are applying, so from the given condition, for example like this problem is there. So here this is media, glass media, water media, and air media, other side. So light is grazing coming from this water media and coming from glass media. Means initially it is starting here. So normally consider here. So water and glass, water is rare medium with respect to glass. So it is coming like this. Means arrow marks are given like this, means the refraction starting from glass media, means incident starting from glass media, refracted in water media, and again like this. So your refractive index of glass media is equal to 1 by sin A. So if you take sin A by sin R, the Snell's law, so it make you confused. So this rule we follow: Ng, refractive index of glass media into sin of incident is equal to n water into sin of refracting angle. So this is equation 1. And again here sin of, here also this angle r means here also angle r. Therefore n double into sin r is equal to 1 into 1. Therefore Ng is equal to 1 by sin. So this is application of Snell's law for given any surfaces. If there are 3 or more surfaces, means the same method will follow. N into sin of incident, sin of angle in that media, that is incident or refraction. So that is out of matter. So coming into, so this is about the introduction about refraction, the nature of the media, refractive index, absolute refractive index, and the relative refractive index. And here I forgot to tell about the refractive index. The refractive index is inversely proportional to velocity. So refractive index is inversely proportional to velocity, and n1 by n2 is equal to v2 by v1, inversely proportional. So that equal to frequency constant, therefore lambda 2 by lambda 1. So this is under refractive index. And the second law of refraction, That means incident ray, refracted ray, and normal at the point of interference drawn lie in the same plane. So the vector law of Snell's law we can write like this: n1 into I cap cos n cap. That means in n1 media incident ray is there, and these are the unit vector of incident and perpendicular vector is equal to the refractor ray unit vector along the refractor ray, the unit vector along the refractor ray, and normal cross product of normal into n2. This is vector form. Means for example they have given one example is there. I'll try to explain. 6 I cap plus 8 j cap plus 10 k cap is given. Suppose. So now here the incident ray is there in xy plane. So then z xy plane means z plane or z axis will be the normal. So now you have to z component is along normal unit vectors you have to find out for incident unit vector. That means the given vector by magnitude of that vector is unit vector. The normal vector by magnitude of normal vector, that is unit vector cross product. Will give the r cap into n cap. So this is calculation of vector form of vector application of Snell's law. So now refraction glass law we'll see. So refraction glass law applications are apparent depth to real depth. Real depth means this is consideration. We'll consider where the object is lies or thickness of the glass law. So the refraction phenomena through glass law gives the concept of vertical shift, lateral shift, and on plane surfaces T.I.R and optical fiber. T.I.R application is optical fiber. In the glass law, vertical shift and lateral shift concept we'll study. So here you can see the ABCD one rectangular glass slab is taken, and it is the incident ray is given here from one media to glass, glass to another media emerging. So angle I is incident angle, angle R is refracting angle, and I minus R is deviation angle. Angle E is emergent angle, and X is equal to lateral shift. And here the vertical shift. These 2 points is called vertical shift. B and E. B is vertical shift, and here some A dash and E is apparent depth. So A dash is apparent depth, A dash E, and B E are vertical shift. BC is lateral shift, and AB is refractor ray, and angle A means BAD is angle of refraction, and I minus R is deviation angle. Angle E is emergent angle. Lateral shift means the perpendicular distance between incident ray and emergent ray. And here, so maximum there is no refraction condition. So for example, the light incident on the glass slab perpendicularly. So the light incident like this, perpendicular in perpendicular direction, no refraction takes place because no deviation. According to definition of refraction, at the interference there will be deviation, then it will set to be refracted. Right, light is refracted. Otherwise, this is one condition. Otherwise, the medias are same. Physical properties of mediums are different, and chemical properties also different, but they can have same refractive index. In that case, the light will travel in same path, along the same path. Here also, y will tell me same media, so no deviation, it will go in straight line, so no refraction taken place. These are the no refraction conditions. So no refraction take place, normal incident, and traveling through same area. So coming into here also deviation is equal to 0. The total deviation by the glass slab is equal to 0. Because emergent ray and extended incident are parallel, so deviation is equal to 0. By that we cannot tell that refraction not taken place. So if refraction not taken place when you will say me, then x is equal to 0, we will say no refraction take place. X equal to 0, no refraction take place. This is also one of the conditions. But here x will be lateral shift not equal to 0. Means x equal to 0 means it will be fall along the line of incident. So the emergent ray is fall along the line of incident, then no refraction taken place. But emergent ray and extended incident are parallel. Deviation 0, but they are parallel. So refraction taken place to the glass slab. In that no doubt at all. Coming into finding the lateral shift first of all. So lateral shift is x. For that I am taking the triangle from the triangle ABC. If you take triangle ABC, in this ABC I minus R is the deviation angle and opposite to the x. Therefore sin of I minus R equal to x by AB, and cos R is equal to AD by AB from the triangle ADB. From the triangle ADB, cos R equal to AB by AD. So here why sin R cos R values I am considering means to find out the lateral shift, and these angles are not small angles. If small angles means in the small angle approximation, say I minus R equal to I minus R only will consider. In the prism and lens formula, mirror formula, in light maximum, small angles only will consider. Small angle approximation. R equal to F in every case. So now coming into here, substitute these values in the place of x equal to lateral shift is equal to x is equal to AB into sin of I minus R. So then AB is equal to AD by cos R. Substituting, you will get this is answer for larger angles. The lateral shift x equal to T into sin of I minus R. So this will be expanded sin of A minus B, and applying the Snell's law for this glass slab experiment, and cos R eliminating by substituting the sin I. Cos R eliminating by substituting in the sin r place sin I by n. So we will get lateral shift is equal to T into I of, so finally T into I of 1 minus 1 by n after small angular approximation. For small angular approximation, sin I is equal to I, cos I is equal to 1. And this lateral shift depends on NIT. It is not a National Institute of Technology. It is refractive index, angle of incident, and the thickness of the glass slab, means real depth. So the lateral shift does not depend on refracting angle, because for two plane surfaces, n into refracting angle, sin of refracting angle, and n into sin of refracting angle, and the two surfaces get cancelled. So n1 into sin I is equal to n1 into sin r only will come. So according to Snell's law, right? So this is about the lateral shift and depending factors for small angles and bigger angles. Bigger angles means T into sin of I minus r by cos r. Small angles means Ti into 1 minus 1 by n. N is refractive index, the thickness of glass slab. Coming into apparent depth concept, apparent depth, real depth, and where the image will appear the person under. Applications of refraction. One of the application of refraction, the calculation of apparent depth and real depth. So here diagram is given. So there are many lines. Once you can, I am explaining one. See these lines under the glass slab. First of all, glass slab. So inside the glass slab there is a dot r. This is there, and it is so incident. So once again I will draw this because some adjustment happened here. So for neatly I will draw this. So consider a glass slab here. So here is the fish. So here is the eagle in the distance y. So A and E. AE is the eagle position from the glass slab, and this distance. So F dash. So BF is thickness of the glass slab or real depth of the fish. So now the light ray is traveling from fish. So now because of refraction phenomena, the light is bent to the eagle like this, away from the normal. So this is angle of refraction. So then this is also angle of refraction. So this is position of E. That means for the fish which is observing the eagle, it appears far than its actual position. So E dash, E dash is apparent depth. So D, it is not actual depth, apparent depth. So AE. So now here if you follow the sign, this is angle I, this is angle I, and then this also angle I. So here also angle I. If you are writing the sign of Snell's law for small angles, then apparent depth is equal to n into real depth. That means it appear far. Similarly, if you change arrow mark, principle of reversibility will follow. The fish appeared here. So this is F dash. Means for eagle, the light is appearing from this image of the fish. So now this length is called, this length is apparent depth of the fish. And that vertical separation between real depth and apparent depth is called shift. This is vertical shift. So here vertical shift is equal to real depth minus apparent depth, or apparent depth minus real depth. So it is in rare media, it is in denser media. So in denser media, real depth is equal to thickness. I have taken thickness of the glass wire. Apparent depth is equal to real depth by n, T by n. So that is equal to T into 1 minus 1 by n. Means you are observing the objects in denser medium, thickness will be T into 1 minus 1 by n. That means shift, vertical shift will be T into 1 minus 1 by n. If you are observing the object in rare medium from the denser medium, so shift is equal to, so E dash, that means AE, apparent depth minus real depth, that is equal to n minus 1 into real depth. N minus 1 into real depth. So now we can derive this vertical shift. We will get the relative position of image also, image of the fish or image of the eagle. So that we will discuss. And because of this apparent depth and real depth, the fish is estimating wrongly about the eagle position, and eagle is estimating the wrong position of the fish. So because of refraction, they are not appearing at actual depth, they are appearing at apparent depth. In denser medium, apparent depth will be lesser than the real depth. In the rare medium, apparent depth will be more than the actual depth. So when you want to aim the fish with a gun or bullet, you have to aim below than image of the fish appearing. You are aiming with a laser gun, so directly you can aim. It is the light, so it chooses its path. It refracted and goes to the fish where it is automatically. When you are aiming the gun, bullet, normal bullet or arrow, you have to aim below the image of the fish where it is appearing. When you are aiming with a laser gun, then directly you have to aim the fish. Then light will go to point of fish. It will touch that, right? So this is about this. That is the reason our friend who are standing on shoreline, they will appear taller in height. So than actual height. So this is now, and in this case, so in shift case, vertical shift case, when a divergent beam is there, so across the divergent beam, we are placing a one glass slab. So then shift is towards, so your O to I, shift is towards the glass slab will take place. I have given, see, divergent beam, arrow marks take care here. So divergent beam, arrow marks. So refracting and emergent. So this extended emergent rays are meeting here. This is the shift. O to I is shift towards glass. If now the across the convergent beam I am placing a glass slab, then the shift will move I to O, that is away from the glass slab. This is one important. So convergent beam and divergent beam. Divergent beam means, you know, moving away from the point. Convergent beam means converging, means meeting at that point. So this is about the beam across the, means glass slab across the beam. Divergent and convergent. Divergent means moving towards the glass slab. Convergent means away from the glass slab. So for both the same diagram, arrow marks alone you can change. So that is principle of reversibility. Light has only one path. The light always choose only one path. So that is given by Fermat, and the path is least time taken path. So in reflection phenomena, least time taken path and least path are both are same. But whereas refraction phenomena, the least time taken path can be longer and the least path can take more time. So that explanation, if I have time, I will explain that. So here I have explained about how the real depth is n times of, means apparent depth is n times of real depth, and apparent depth is equal to real depth by n in a denser medium and rare medium. Here I have given from the diagram. So you can see here. So this is under, and the vertical shift also explained here. And cases here, there are glass slabs are there of refractive index n1, n2, n3, and media is having the same thickness. So here thickness. So then total shift is equal to T into 1 minus 1 by n1 plus T into 1 minus 1 by n2 plus T into 1 minus 1 by n3. And here same thickness, so T I can take common, T1 T plus T plus T nt minus T into 1 by n1 minus of T into 1 by n1, 1 by n2, 1 by n3 and so on. Right. So now, similarly the total apparent depth, that is T by n1 plus T by n2 plus T by n3 and so on. Here T is same, n1, n2, n3 are different. So now thickness of the glass slab is also vary, and refractive index both are vary. Then total apparent depth and total apparent shift formulas. So this you can take. One application I have given here, see once. So on this, so there are refractive index of glass slabs is 1.5 each. That means there are n number of glass slabs are there. So their thickness is equal to 1, 2, 3, 1 centimeter, 2 centimeter, 3 centimeter, and so on, n centimeters. The total shift of the observed is 5 centimeter. Total shift it is, so 5 centimeters. Therefore, total shift is equal to thickness. Here n is constant. N is same for all the slabs. Therefore, 1 minus 1 by n I have taken common. Therefore, thickness 1 plus 2 plus 3 plus and so on, n. So here plus n plus. So therefore, 1 minus 2 by 3 into the sum of natural numbers n into n plus 1 by 2. So if you do this one, you will get quadratic equation and the number of glass slabs are 5. So that is one of the application. In some applications, the same thing they can ask total depth also. Same formula, T by n plus T by n plus T by n. So total apparent depth, if they have given means, so thickness of the each one is given 1 by 1.5, 2 by 1.5, 3 by 1.5, and 1.5 I will take common. Then sum of n into n plus 1 by 2. So 3 will come. Then you can calculate. So now coming into next application, T.I.R. So total internal reflection on glass slab. So here this is C1. So this is one of the case, that is incident angle from rarer to denser medium, and reflected ray and refracted ray are perpendicularly moving. So that means I and R, angle I here, angle R, refracting angle, and the angle between reflected ray and refracted ray is 90 degrees. So therefore, apply the Snell's law. Here we will get n1 into sin I equal to n into sin R. So now R equal to 90 minus I, and n equal to tan I. So this I angle is called booster angle. N is equal to I is equal to tan inverse of refractive index. This is rarer to denser. So similarly, denser to rarer means n is equal to cot I will come. And always here I am writing n means this is n2 by n1, relative refractive index of second media, denser media. So in critical angle also, when they are writing sin c is equal to 1 by n, so there I will come. So sin c is equal to 1 by n. That means we have to take relative refractive index of denser media. That n will be relative refractive index. That too, that is denser media's refractive index. So right. So coming into T.I.R, total interreflection. So why we named it as a total internal reflection, we'll understand here. Why not it is reflection? What is the difference between the total internal reflection and reflection also? Here I'll try to explain. So now the light is incident, and this total internal reflection only will observe when traveling from denser medium to rarer medium. So this is very important. Denser medium to rarer medium means object in the denser medium or the refraction phenomena taking place from denser medium to rarer medium. So the light can come into this denser medium from any medium. So once it is denser to trying to go to rarer medium, the other medium is rarer. So at the certain incident angle, the total interreflection takes place. So then it is continuous until it comes out. So this phenomena will apply in optical fiber. There I will explain. In the optical fiber, so here see, so this total internal reflection is one of main application in T.I.R. In optical fibers. So now how the optical fibers are helpful in our this much development. Today we are seeing many developments, industries, robots, mechanics, machinery parts, medicine, and telecommunication mainly. The major tremendous changes in telecommunication and medicine because of optical fiber. The like in the 1919s, 1930 time, after Faraday's law, how today you are feeling all AC means applications of dynamo and that electromagnetic induction, everything, ACs, mobiles, and this induction stoves. There are many things because of Faraday's law, Faraday's that electromagnetic induction applications. So more tremendous development is came. The same way here, optical fiber also same like that. So now total interreflection phenomena. Who invented and who observed this and who are introduced to this? For them, really, they got Nobel Prize. I don't know exactly. Sorry for that. So really, accept to them. Now, so this total interreflection when light ray is traveling from denser to rarer medium will happen. So here I have given ray C, first ray, second ray. Coming into third ray here, not only third ray, after many rays, one of the ray is grazing along the surface as shown in the figure here. The grazing along the surface means the angle of refraction is 90. So where in the rarer medium, angle of refraction for the incident ray is 90, that incident angle is called critical angle. So this incident angle is called critical angle. So where this critical angle is there, then deviation is equal to deviation. This is the deviation angle that equal to pi by 2 minus. So this is C and total is pi by 2. The deviation is equal to pi by 2 minus. So this is when grazing along the surface. When it is internally reflected, then total deviation is equal to pi minus 2c. C will become critical angle. So internal reflection. So it takes place when the incident angle is slightly greater than critical angle. So in some explanations, in prism case and in optical fiber, these conditions will apply. So it is internally reflecting means the incident angle should be greater than the critical angle, then only internal reflection takes place. So this is reflection will call. Means same media it is coming light. So here the difference between this internal reflection and normal reflection means when reflection taking place on mirror surfaces, the light absorbed by the media and some amount maximum means some amount will be absorbed to become heat of the surface. That is the reason when you are placing a mirror on sunlight and if you touch means it will become hot. That means it absorbs the energy. The reflected and at the same way absorbs. So whereas in total internal reflection and the refraction phenomena also there will be a reflection and refraction. Partial amount of light is reflected. But in the total internal reflection, that is the meaning they have given. Total internal reflection means the light which you sent with some intensity, the same intensity is reflected and comes back to you. That's why this phenomenon is called total internal reflection. Because of this, there is a mirage also will happen. So that is not here discussion. So now, so if you apply the Snell's law, then n is equal to 1 by sin c. The sin c is equal to 1 by n. Here n already informed, that is the relative refractive index of denser medium. No. So coming into optical fiber. So in optical fiber, main parts are core and cladding, and there is a shading, rubber shade, and some mesh, something other things and all there. But main things are core and cladding. And core is made up of refracting material like glass and plastic. Of this core diameter is 10 power minus 6 millimeter, if I am not right. Very small and more thin than our A. So where you will means if you are thorough with endoscope, so they used to send a small pipe to our stomach to observe the parts. Okay, now, where ulcers and related to gastric problem and what type of problem is there in our stomach. So there, in endoscope phenomena, they use this type of pipe. So that in that pipe, very small pipe, they used to send light with light. So that will be reflected and give the information on monitor. So in sending the light into this optical fiber, so much maximum angle should be. So here this is the angle of incident into the optical fiber. The light is incident into the optical fiber and it is refracting from the cladding surface. That means total internal reflected into the core material. That means core material is denser medium. The cladding is rare medium. Means refractive index of cladding is less than core material. Core is more refractive index material. So now here if you see the diagram, the angle R take place here and R1. So 90 degrees here. So R1 is 90 minus R. R1 should be greater than C. Sin R1 greater than sin C. Sin C means N1 by N2, that equal to N1 means here refractive index of air media 1 I can write. So that is N1 by N2, 1 by N2. So apply the Snell's law here. 1 into sin I according to our rule, refractive index into in that medium sin of the incident angle is equal to N2 into sin R. So here sin R I can write 90 R equal to 90 minus R1 according to diagram, then cos R1. The cos R1 is equal to again cos R1 is equal to root over 1 minus sin square R1. Because sin square theta plus cos square theta is equal to 1. Cos square theta equal to 1 minus sin square theta. The cos theta is equal to root over 1 minus sin theta. So now sin R already I got here. Sin R1 is equal to N2 by N1 by N2. So that is N1 by N2 whole square. Here N2 is refractive index of core and N1 is refractive index of cloud. N2 means more number, so more refractive index media's representation. So this is I maxima is equal sin inverse of N core square minus N cloud square or N2 more refractive index minus less refractive index square. So this will be total internal reflection application. And theoretically some bits are there that you can study. And coming into refraction plane surface, glass slab, critical angle, and this one only. So in critical angle, so one application I will tell. For example, here, so there is a surface. So this is the surface separating the water media and air concern. So in the water media, there is a one piece in the depth h. So how much area it can see? It want to look into sky. Okay, how much area it can see from this depth? And it want to see more area, how much deep it has to go. Or if deep increases, what happens to the area, the observing area? We will see now. So here it is observing, this is area means this is the radius of this area. And from here, the light is internally reflected. So this is sin C and here also C. So now, according to Snell's law, sin C is equal to 1 by N, that equal to sin C is equal to 1 by N, that is here 3 by 4. Water media, N is refractive index of water media 3 by 4. Air and water media, therefore 1 by 4 by 3, that equal 3 by 4. So from the diagram, sin C is equal to opposite R by hypotenuse, that equal root over R square plus H square. So that equal to 3 by 4. Now I want R value, the radius, how much area it can see, radius, then pi R square I can multiply. So therefore, squaring on both sides, R square is equal to, R square into 4 is equal to, squaring on both sides and cross multiply, will get 3R square plus 3H square. Sorry, 9R square, squaring on both sides, 9H square and 16R square. So that equals 7R square is equal to 9H square. Therefore, radius is equal to, or R square is equal to 9H square by 7. So now area it can see pi R square, that equal to 9H square by 7 into pi, that equal to 22 by 7, or pi only keep like that, pi H square, 9 pi H square by 7. So this is area it can observe. So now pi 9 by 7 values are constant values because in the water medium, if H is increases, the area is also increases. It want to see more area if it goes to more deep, right? So this is the concept related to critical angle, and the critical angle of water is equal to 42, 45, critical angle of glass is equal to 48. So sin C will take, that means C is equal to sin inverse of 2 by 3. The critical angle of water media is equal to sin inverse of 1 by n, that equal to 3 by 4, 0.75. So that will be 42, I think, 42 point something 5 degrees. The critical angle of glass media is equal to sin inverse 2 by 3. So the 0.66 is more than, that is 48. Right. So maybe these values 48 and 42 can vary. Right, you can check. So now another application on plane surface. So this is related to refract, means apparent depth and real depth concept. So there is a bird and there is a fish. Positions are given 6 centimeters, 6 meters and 0.8 meter. Fish inside the water 0.8 meter and 6 meters above the surface. Now both are looking. The bird observing fish observing the bird. Okay, they are trying to escape, or there is a fight between bird and fish. So we will win now see. So now for bird, fish appears in the apparent depth, that equal to 0.8 into 3 by 4. The bird is looking. It is in the distance 6 meters. Therefore 6 plus 0.8 into 3 by 4, 6.6 meters. Fish is appearing. So now the bird is trying to move with 6.6 meter. It can't catch. So there is no fish and it has to come out. Otherwise, it can die there itself. So it has to go more past to reach more than 6.68 meters. For example, it is appearing at 6.6 meters. That means 0.6 meter extra. Then 0.6 into refractive index times it has to move more. Plus 4 by 3. Then it will reach the point. So it is how much estimated? 0.6 meters extra means 0.6 meters from its position extra is observed. But there is no fish. That is the image of the fish only. If you want to catch the fish, it has to travel. It is planned to travel 6 plus 0.6 into that time many times of refractive index. 0.6 into 4 by 3 refractive index. Then it will reach. So now the same way fish. Fish is observing the bird. The bird appeared in apparent depth that equal to 4 by 3 into 6 that equal to 8 meters above. Actually, it is the fish is thinking that the bird is in 8 meters above the surface. Okay, I can relaxly move, or otherwise I can dance here like that. It can think. But actually, the fish, the bird is not at 8 meters. It is in 6 meters only. So it can means it is thinking that it is coming very faster, right? So it is very far. So no problem like that. But it is not that much far appear. It is appear. It is in nearer than appear. So it appearing after depth. That is equal to 0.8 plus 6 into 4 by 3, 8.8 meters. It expect that 8.8 meters, 0.8 meters means 2.8 meters away from me extra. So no problem like that. So now coming into how to find out velocities here. So this is observer observing the fish now inside the water. So now the distance between B and fish is equal to y plus x by n, that is equal to d. So this is the present distance between fish and the observer. So now derivate, you will get answer dy by dt means the motion of the board, velocity of the board, and dx by dt is velocity of the fish. So now you substituting, you will get answer. So now, so another application. So here variation of refractive index with respect to height. So the medium of thickness T.R. So with respect to y, the refractive index is varying. And here let's consider the thickness of a small element is dy. That means refractive index is varying with respect to y is given mu is equal to root over 1 plus y. And here the light is grazing along the surface which is at y equal to 0 and x equal to 0 origin. So x equal to 0 and y is equal to 0. It is grazing along the surface. So now the refracting into the media of refractive index n. So at x equal to 2 root 2 meters, then y value is equal to how much? So now this light ray is refracting not straight. The light ray is not refracting like this straight, because this media's refractive index is not even. It is varying as given formula. So therefore it will be curved. So find out the slope of this curve, dy by dx, and dy by dx is equal to here tan of 90 minus 3 that equal to cot theta. Cot theta equal to dy by dx. And apply the sign convention for this surface. Snell's law, not sign convention, Snell's law. Then 1 into 1 because grazing incident. So refractive index is 1, sin 90 is 1. So mu into sin theta equal to 1 by mu. So from this sin theta equal to 1 by mu, I will get cot theta is equal to root over mu square minus 1 by 1. So then finding the y equal to 2 will get, integrating from x equal 0 to root 2 and y equal to 0 to y. Similarly here also. So one more application, same like that. But here is given the mu is equal to root over 1 plus a by it is changing, and a value they will go to find out the x value. Alright. So to solve these two problems, I am going with this model C1s. So very important model. This you understand means image and apparent depth. So the above two problems it is easy to apply. So let here in the distance h there is observer from the surface of water tank, and the water filled up to the tank to the height h, and there is a fish or something object therein inside this tank at h by 2. It is not moving up and down, it is fixed. So fish is observing, not going anywhere, observing from the h by 2 from the bottom, from the mirror. At the bottom of this tank is attached to mirror. So now the questions are, so if observer is observing directly observing the fish appeared at the apparent depth. Therefore image of the fish is equal to from the observer h plus h by 2n. What is h by 2n? H by 2n is the apparent depth. Means apparent depth is equal to real depth by n. Real depth means h by 2 into by n means 1 by n, that equal to h by 2n. H by 2n plus h. This is seen by the observer, the image of the fish. Similarly, the image of the bird seen by the fish. So that equal to the image of the bird appear to the fish at n times of h. So apparent depth is equal to, so appearing depth is equal to n into real depth, because we are observing in a rare medium from the denser medium. Therefore more depth it will appear. So nh plus h by 2. So now the image of this image of the fish in the mirror. So fish image is h by 2. The image of the fish alone h by 2. But the image of the fish at apparent depth appeared in the image in the mirror is, so h by 2. This is h by 2 minus h by n. So this distance is equal to this distance is equal to, so h by 2, and here h by or h minus h by 2n directly, h minus h by 2n. This is the distance of image of the fish from the mirror, and now this is observed by observer. That means h plus h 2h, 2h plus h minus h by 2n. So now we will get h of 3 minus 1 by 2n. This is observer observing the, or board observing the image of the fish in the mirror. Image of the fish directly is apparent depth. So that apparent depth is appearing in the mirror. So from that position of the image to the mirror, h minus h by 2n. So that how it is coming here, arrow marks I can see. You can check clearly. This is right. Similarly, the image of the bird or observer observing by the fish. So fish observing, right. So first of all, image of the bird. So now this is nh and h. So nh plus h. This is the image of bird from the mirror. Now fish is in h by 2 height. So this is nh, the fish observing h plus nh plus h by 2. So this is, so these are the 4 cases. The similarly apply now here, and here in this case the free surface, water surface is moving down. So for the observer, the bottom appeared in the distance h minus x. So when this surface is moving down h meters per second, so then the bottom distance is equal to the mirror distance from the free surface is equal to h minus h. Initial height is equal to h. Initially it is h. Now this is h minus h. So now in this case, the apparent depth of this mirror is equal to h minus real depth by refractive index, that equal to 3 by 4 will come, 3 by 4 into h minus x. Actually 4 by 3 denominator, then 3 by 4 I have taken. So now the total distance of the this one mirror is y plus x plus h minus x into 3 by 4. So then image will be double than this height, right? So into 2. So now we will get answer. So this, if you are able to write, means over, answer. So now dy by dt and dx by dt derivating dh by dt, h is constant, h will not vary, so this is 0. So then minus 3 by 4 into dx by dt into 2. So now 1 minus, so here dy by dy also constant here, only x dx by dt, it is 1 meter second inverse, minus 3 by 4 into 1 minus second inverse into 2. So now we will get 1 by 2 meter second inverse. So similarly here one more application. So fish is moving upwards, the bird is moving downwards, and the plane surface also, free surface also moving downwards. So similarly, initially they are at y, x and h distance consider. So now find out the distance of image. So now image observing the fish. So now see fish covered 2t meters and surface also 2t meters downwards. The total initial distance between the fish and the bottom at the bottom only I will take fish here. So then surface is x, initial surface and the fish x distance. So now it is covered 2t and it is also covered 2t in opposite direction. Therefore total 4t is difference is there. Therefore x minus 4t is the present distance of fish and means mirror and surface, between the surface and mirror, or length of the water is equal to water column is equal to x minus 4t. So now the fish appear in x minus 4t by n, that equal to x minus 4t into 3 by 4 distance. This is apparent depth of the fish. And similarly for fish, the board will appear, board or observer will appear. Initially this is y surface to the board y initially. Then it is covered with velocity 5 meters second minus 5t, y minus 5t plus 2t x. This is the this displacement by surface, free surface, initial to time 2 seconds. 2t is the distance traveled by the free surface. Therefore 5t is the distance traveled by the board. Therefore y minus 5t plus 2t is the present distance between surface and the board. So now the fish will add this one, we will get the image of the board is equal to from the surface y minus 5t plus 2t directly seeing into 4 by 3. It will appear, not appear at y dash, it will appear somewhere bigger than y dash, that equal to sub 2t means you will get 4. Otherwise simply you want to get this formula means, so relative velocity by velocity of the image is equal to relative velocity of the fish by refractive index. The velocity of the board image, velocity of the image of the board is equal to refractive index into relative velocity of the board. So then you will get the answer, same answer you will get. So now clearly now, so now fish, the image of the fish where it will appear. So now this is, so here already I have marked all the points. So I am telling you now, from the image of the fish, so you have the apparent depth of the fish, the mirror distance find out. Virtual mirror distance means initial position, real depth, that equal to this much will come. So x minus 4t minus 3 by 4 of x minus 4t. So that is image distance. And the fish is means observer in the distance to the mirror is y minus 5t plus 2t plus x plus 4t. This distance here to here distance, this distance, and this distance x minus 4t, right? So now we are adding means you will get answer. Means derivating with respect to time, dx by dt, dy by dt, all are cancels, only the values are remaining, that will be get answers. Similarly this one also. So I hope you understand this concept. So there are many applications are there. So one more application I will give. So this is important. So this is glass slab. means beaker. So in the beaker there is a glass slab. So surrounding pour with water. So now the glass slab height is equal to h. So now the two rays are traveling. So one is only through the water medium to the bottom, and one is through the water medium and pass. So now we'll ask here what the time difference taken to reach the bottom. So your time taken by this one is equal to distance by. So this distance of water is equal to some x consider. So x by the speed, right? X by speed of the light in this one medium. So speed is equal to, I can write c by n, that equal to n into c, n by c. So t is equal to x into n by c. N is refractive index, c is light velocity. So now this one apply for this second ray. For second ray also apply. So now second ray is traveling some time for, so t1 time for water medium, that equal to x into n of the water by c. This is n of the water by c. So here also n of the water by c. And next time it is traveling through the glass slab, that equal to h into, this is here h minus x. This is x minus h. So x minus h into n. So h into refractive index of glass by c. So refractive index of water is equal to 4 by 3, that equal to 4 into x minus h by 3c. So this is 3 by 2 mg 3h by 2c. So now total time taken by the second ray, the time taken by the second ray is equal to 4x by 3c. So now this is 3h by 2c minus 4 minus 4h by 3c plus 3h by 2c. So LCM you take, and here subtraction difference is asking. So this 4x by, so here 4x by 3c will come. This is, so now this 4x by 3c, 4x by 3c get cancelled, difference. So now LCM is minus 8h by 8h plus 9h by 6c. So that equal to h by 6c. For example, one more application on this fraction. So here there is a beaker. So here the light ray is coming like this. So if it is a air media, it will go to this bottom consider. This is the B width. So now the water poured up to the side. So the side up to the side. Then because of water it bent. Bent right here take place bent. So when there is no media, there is no medias. Both is same medium, air medium. It will be undividedly travels to this point. So now it bent and touches to some one point. Either it is middle point or some point is given. So this is x. I have to find. So now apply the Snell's law again. So this is r. This total is, so here normal. So incident angle. So now this is incident angle, and this is I minus r. So now this is I mean this is also I here. This is r means, so here I can go with r. So this is nominal as well. So now the refractive index of water. This is the height h is given, and this is some x. Therefore, tan r is equal to x by h. Similarly, tan I is equal to x by means h by means b by h. So now I and r values have to find out. So if I apply the Snell's law, 1 into sin I is equal to n into means refractive index of this media 4 is equal into sin I. So then sin r is equal to sin I is equal to n into sin r. So now from this value sin I and tan I and tan r values you can substitute, you will get answers. So this is one of the applications. So where it will appear directly. So I and values are given. Otherwise directly sin I you can find out. H and x is given. Sin I you can substitute here. Sin I is equal to x by root over h square plus x square is equal to n into n means water medium, that equal to 4 by 3 into. So this is sin r value. Sin I value means b by root over b square plus h square. Now x by root over h square plus x square. So now, so b is the width of the tank they have given, and h is the height of the water port up to the height of the water port. So at what distance, up to what distance, what is the shift happened or what distance you can see, or where it will be touching the bottom. So like this distance they will ask. So coming into square on both sides, b square by h square plus b square, for sin I this is equal to 16 by 9 into h square by h square plus x. So now the b value you know means you can find out, and okay h values you will find out, you know, 9 9b square into h square plus x square is equal to 16 x square plus 16b square. So 9b square 16b square into x square. So b square stand that same stand and h square this side. So now minus 7 x means minus 7 b square x square x square. No, not this. So now here 16 b square, I want h square. So now 9 b square h square minus 16 b square x square is equal to, so 9b x square and b square x square minus 16 plus 6, this is minus, this is 16 x square x square. So now, so the values are given means b, any b value is given means b and h value we can find out x value. So if b value you know, you can substitute the refractive index and sin I, sin r and tan I. H and b value means tan I value in a sin will substitute and will find out. So this is final answer. Right. So like this we can find out, and there are many applications on refraction on plane surface. There are many applications, and curved surface I will take in the next class. Thank you all.